Okay, asikhulume ngo question 6 again. This is work, energy and power. Now, in the description box uzothola ama links for other questions engiwaphendulile for this June examination 2023. There's also a link to another channel for ama lessons. Check it out. Now, a subscriber to that channel, I'd appreciate it. Thanks in advance. Thanks for tuning in. Now, I see teklishe le question again, man. Now, Lanabati, the diagram below shows a fairground carriage moving at a constant speed of 9.5 meters per second over a frictionless surface. Right, so A to B, I believe it's frictionless, but as Kubek is found, but the total mass of the people and the carriage is 600 kilograms. The carriage moves up a slope inclined at 30 degrees to the horizontal. The carriage comes to a stop after traveling up the rough surface to a vertical height of 4.5 meters at point C. So it moves from A to B where there's no friction, then from B to C there's a rough surface la. Then you move all the way up is a figure kupana ku point C, then it comes to a stop. Yes, it comes to a stop. 6.1. But again, state the work energy theorem. The work energy theorem in words. So the work net done is equal to the change in kinetic energy. So see, define the work done on an object by a net force is equal to the change in an object's kinetic energy. Right? So this is the definition in words. Lana was just writing down the equation. 6.2. Calculate the kinetic energy of the carriage and passengers as they reach point B. 6.2. So sifuna the kinetic energy EK at B is equal to half mv squared at B. This is equal to half mass, it's 600 kilogram times velocity at B, which is 9.5 squared, equal to, we calculate 0.5, which is half times 600 times 9.5 squared, equal to 275 joules. So now I answer here together. 6.3. 6.3. Draw a label free body diagram of all the forces that act on the carriage while moving up the slope. 3. Sifuna all the forces are acting up the acting on this carriage. Sine normal force, sibe frictional force, sibe nani the weight. Yes, 3 marks. 3 marks. 3 marks. Frictional force, and then sibe weight again. So this is our free body diagram. What's next? So 6.4. But use our energy principles to calculate the frictional force between B and C. Some students, they get confused with these questions where we calculate using our energy principles. Lana, it's up to you to say which formula. Also, there's work done by non-conservative forces, which is the change in kinetic energy plus the change in potential energy. Right? This is one of the formulas as C7 lagu work energy and power. There's also the change in kinetic energy. Work net is equal to the change in kinetic energy. It's up to you to say which formula, this one or this one. This one or this one, right? Puma good. Nabati use our energy principle. Sometimes use the work energy theorem to calculate. for example. So lana I'm going to stick with work energy theorem. The other equation, man, there's too much to calculate. So life, man, yenza ibe simple, ungayicomplicate, uyabona. So sebenza work net equal to change in kinetic energy. Naso but it's calculate the frictional force between B to C, right? All right, again. Now lana sizo calculator the net work done. How many forces do we have? Remember, this is not Newton's first law or second law. Angisho ku Newton's first law is calculate ubani F net. Oh, ungayi approach kanjalo, it's still fine, but I think it would be easier if sisebenzisa ama forces as a whole, right? Ngoba this normal force does work, this frictional force does work, this weight also does what? Weight. Okay, I'm thinking. All right. Okay, let's try this one. Ngoba angisebenzisi kakhulu this method, and on this channel angaze ngayisebenzisa, right? But on other lessons where ngifundisa khona, I would apply this method, right? But okay, how about Caesar? Ngoba usually I use Newton's laws. Now this method is cool now, ne? It's cool. Zoyibona. All right. Bheka ke manje. So we calculate the work done by friction, calculate the work done by this weight, calculate the work done by a normal force. Yes. Now this thing idinga a little bit of geometry kancane, ne? Idinga a little bit of geometry kancane. Bheka ke manje. CT ulokanje friction does work, plus weight also does some work, as well as normal force. So ngamanye amagama ngithi we are going to calculate the work done by friction, the work done by weight, and the work done by normal force. Now I add wonke anginikeza ubani W net work done. And then on the right hand side ngiyoba nobani no half mv b c squared minus half mv b squared. So right, which is the final lapha ku C, and then the initial ku P la ku B. All right, again the work done by friction, the work done by frictional force. Okay, atingithi la let's start nge friction. I'm sure we know that that work done is calculated as force times distance times cos theta, right? So the work done by friction now, it's F times delta x times cos theta. F is what we want to calculate. Delta x I can calculate using using POT, Pythagoras theorem, right? In the opposite side I want the hypotenuse. I'm also given an angle, right? So using Pythagoras theorem I can see that length BC or delta x is equal to, yes, it's okay, so opposite hypotenuse, so sine 30 degrees is equal to opposite, which is 4,1 divided by hypotenuse, OBC, cross multiply ngithola ukuthi it's BC sine 30 degrees is equal to 4,1, right? Now divide both sides la, or sine, I can see that the answer I'm about sine 30 degrees, cancel BC, the hypotenuse yobani, or the hypotenuse BC, which is also delta x ubani, 4.1 over sine 30 degrees, over sine 30 degrees. So asibeke la, siphakhe net la, delta x is equal to 4,1 over sine 30 degrees, right? So delta x is covered, plus what's this? It's the weight, work done by a weight. It's this one again, is about mg, right, which is the force times delta x now delta x times cos theta. So substitute in a moment, plus work done by normal force is equal to 0 degrees. Why do I say that? Normal force is a perpendicular force. The angle lana is what? It's 90 degrees. By the way, the angle is always measured against the direction, clockwise to the direction of motion. Direction of motion is always measured anti-clockwise to the direction of motion. Sorry, anti-clockwise to the direction of motion. Back. The angle from the direction of motion to the normal force is what? It's 90 degrees. If theta is 90 degrees, kule formula yakho le, cos 90 degrees is equal to 0. If your cos is 90 degrees, this whole thing yoba 0. Okay, so that's why I need all perpendicular forces, which is a normal force in this case, is what is equal to 0 degrees, equal to, since the object here tunayifika la ku C iba stationary, it means that the final velocity kuba ubani u 0, meaning the kinetic energy is also 0. So kuba 0 la minus this value calculated lapha phezulu, kinetic energy at B ubani 27075. Now answer yethu, I mean, okay, I see answer yethu, but this is what we are supposed to substitute la. Then see a substitute la, city f delta x or 4,1 over sine 30 degrees. Okay, ngibona ngathi uptile untidy niso. How about see calculator la, basithole the value 4,1 divided by sine 30 degrees equal to 8,2 meters. Uyabona ngenzeni ngishayile eceleni singayi substitute, but you need to show that calculation. So like about cos 180 degrees, ngoba the angle from the direction of motion to friction 180 degrees, plus substitute again. What's the mass? 600, 9,8. I'm substituting la, times 8,2 times what's the angle for theta ke manje. I'm sure this weight in our components. What is the value for this angle ubani? 30 degrees. So lana it's 30 degrees. Nasibuyela ku maths, we know that the Cartesian plane yethu ama angles ahamba njani. 90 degrees, wait, it's 0 degrees, 0 degrees, 90 degrees, 90 degrees, 180 degrees, 180 degrees, 270 degrees. Now 270 degrees la. This 200 degrees, it's this parallel line which is in line with the normal force, right? So in order to find the angle from the direction of motion all the way up to this weight, right, sizoti 270 minus 30 degrees in ngayiki 270, it's 240. So the angle like about 240 degrees. So give about cos 240 degrees equal to 0 minus 270 75 about negative 270 75. Then we simplify again, I think 70 blue spot. So 82 times 8.2 times cos 180, it should be negative, yeah, it's negative 8,2f. Then she calculated this part. 600 times 9,8 times 8,2 times cos 240. Now answer f luna, so it's minus 24108. 24108. Now answer here too. Then we go minus 8.2 frictional force. We transpose this one, you figure a little negative, so this is negative 27075 plus 24108. Answer negative 2967. Divide argument, divide by negative 8,2. Now answer it 361. Frictional force, it's 361,83 newtons. This is our answer. Answer it to see thola kanjalo. This is one way of doing it, ne? Whenever u consider iloganje ama u calculator ama loganje ama you work done using the forces from kuloganje ku free body diagram yakho. If awufuna ukuyenza this way, you can apply Newton's law, where you calculate the F net la, then uthatha F net wakho umsebenzise to calculate iloganje I network done. This is another way of doing it. Okay, asize la ku 6.5. A small tractor is rated at 9 kilowatts and pulls an empty carriage across the ground at a constant speed with a horizontal force of 300 newtons. 6.5.1. But is it define a non-conservative force? This is a force at which the work done in moving an object between 2 points depends on the path taken. Depends ball pen nangaba kusu calculator kuba u ball pen yini kanqani on the path taken. On the path taken. So an example of a non-conservative force, it's something like a force of gravity. Yes, so this is the definition. 6.5.2. Calculate the time it would take the tractor to tow the empty carriage over a distance of 850. Now sifuna the time taken. I'm also given a power. The power is given as 9 kilowatts. We don't work with our kilowatts with my calculation, so we say multiply by 1,000, so it will allow 9,000 watts. This is the power output, right? So in a force which is 300 newtons, sifuna ini iskhathi. I'm given power as well as a force, right? Oh, I'm given with delta x as well, 850 newtons. Sifuna ini iskhathi ke. Sifuna ini iskhathi. So kwamele sisebenzise the formula for power, which is work done over change in time. I have power, I want the change in time. Let us calculate the work done. So work done is equal to force times delta x times cos theta equal to so the force with 300 bukeka to 850 la 850 times cos. What is the value for theta la? Looking at this tractor, we see that the direction of motion is to the right, the force applied is to the right as well. There's no angle between the steering and the carriage, né? So it means that like about 0 degrees. So the force is to the right, the direction of motion is to the right. That's why it angle here to about theta. 300 times 850 times cos 0 degrees. Answer 255,000 joules, right? Therefore, what is power on 9,000 equal to what is work done? 255,000 divided by T over 1, cross multiply T over equal to 255,000 divided by 9,000. Answer 255,000 over 9,000. Answer again 28,33 all the way up to infinity seconds. Now answer it again. It takes 28 seconds. It would take 28 seconds. Now last question. How would the time change if a tractor with a greater power output was used? How would the time change if a tractor with a greater power output was used? Write down only increases, decreases, or remain the same. And I believe ngathi we should also explain yes, okay, the question paper iphelelanga la, but the answer yethu la, it should be decrease. It should be decrease la, ngoba I see that power is equal to work done over time. So by increasing power, what are you doing? You are decreasing in isikhathi, ngoba there's an inverse proportion between the two. So that's why it decreases. So the reason why I provide is just to say power is inversely proportional to time. So this is how the calculation goes for this lesson, for this work, energy and power. So yeah, lesson iphelela lana guys. Now abuna question asikhulume in the comment section. Ungakhohlwa ukulike, ukushare nokusubscribe, as well as ukusubscribe to the other channel in the description box. Kunama lessons ungawa enjoy ngale, I'm sure of it. So for now, asibonane on the next video. Bye bye.